Okay, here's our video today, Trigonometry, Algebra 2. Today we're talking about trig ratios. And there's 6 of them, so let's look at them. Let's get our pen. Maybe red goes with this green, whatever this green is. So we know we have sine, and on the calculator, looks like sin, right? And then there's cosine, COS on the calculator button. And we have tangent, get a tan. So those are the 3, and then they have their reciprocals. The reciprocal. When you flip the fraction, right? So this would be 1 over sine, and then there's 1 over cosine, and 1 over tangent. So 1 over sine theta, this would be cosecant. And that's the reciprocal of sine. And 1 over cosine is the reciprocal of cosine, right? And that'll be secant. And 1 over tan will be cotangent. And the way you'll see them with their abbreviations on the calculator, this would be CSC, this would be SEC, like second, and this will be COT, cot. So those are the six ratios. And today in the video, we'll look at how we can apply them with a 90-degree triangle. All right, and here's our triangle. Why don't we just keep red, stick with red today for this one. So as you can see, we have a triangle here. We have a 90-degree triangle. There's that little box. And let's say now we'll just label these. We'll say that's A and that's leg B and this is the hypotenuse. Remember, the hypotenuse. The hypotenuse is the longest side of a right triangle. And let's say over here we have an angle, and we don't know what the angle is, so we just say angle theta. Or theta, however you want to pronounce it. So angle theta is just a degree we don't know yet. It's the unknown degree. We're trying to figure it out. That's why we call it angle theta. But then you could hear it as angle or see it as angle alpha sometimes or anything. It doesn't really matter. Sometimes they put an X there. So if we're looking at angle theta right here, and if I look at the opposite leg of the triangle, there's my arrow, that's opposite. So that's opposite this angle. So when we're dealing with sine, we'll say sine theta because we don't know what it is yet. We're looking at something that's opposite the angle and then the hypotenuse. So opposite the angle is A and the hypotenuse is C. So that'll be the ratio, and we'll apply that in the video. The ratio will be opposite over hypotenuse. And you'll hear this word so. It's a way to remember this. So katoa. We'll do the ka part in a minute. So then if I said cosine theta, well, cosine is adjacent to over hypotenuse. So let's look at this angle right here. What's adjacent to it? What's next to it? Right here's the arrow. It'll be B. That's adjacent. So adjacent would be the B over the hypotenuse, BC. B, here's the B, C. And we say ka, so ka. This will make sense in a minute. Or maybe you know it already. And then if we take tan, we'll just concentrate on these 3 ratios first. Tan is opposite over adjacent. So here's the angle. Here's the angle right here. Opposite is B, as A that is. Opposite is A, and adjacent is B. So we have so from sine, opposite, and the hypotenuse. Ka is cosine, adjacent over hypotenuse. Toa is opposite over adjacent. So SOHCAHTOA is just a mnemonic device, a way you can remember these angles for the first 3, not the reciprocals. All right, so let's apply this. Actually, let me use green to show you. Let's use the other three, the reciprocals. So we had sine, cosine, and tangent on this side. And then what if we had cosecant? Cosecant. What would be cosecant? What would be secant? What would be cotangent? Sometimes you see that for cosecant. So you either see that or that. Most of the time it's that or that. It doesn't matter. So cosecant, remember we said cosecant is the reciprocal of sine. So instead it'll be the hypotenuse over the opposite. So if this is the angle we're looking at, this angle here, the hypotenuse is C and opposite is A. C over A. Secant is the reciprocal of cosine, so that'll be hypotenuse over adjacent. And what will that be? C over B. You got it. And cotangent is the reciprocal of tan, so that would be B over A, which would be the adjacent over the opposite. All right, let's apply this. It'll make more sense. Let's clear this out. So let's say we had over here, we had a 45-degree angle. Now, if this was a 45-degree angle, you wouldn't see these two, the leg A and leg B, have to be the same. They have to be the same. So you wouldn't see this double line here. This would be the same line, the same angle. Because remember, in special triangles, in a 45-degree special triangle, a 45, 45, 90, leg A and leg B are the same. But we'll continue on. Let's say that the hypotenuse is 2. What would A be? Now, you can figure this out, obviously, with knowing the 45, 45, 90 rule. But let's try to figure it out anyway, without that rule. And then I'll show you the rule. So if we take this 45, we can do opposite the 45. So we have opposite over the hypotenuse, so that's sine. This is going to be sine 45 degrees because it's opposite over the hypotenuse. So sine 45, we don't know what the opposite is. We just have it as A, and the hypotenuse we have is 2. So we have sine 45 degrees equals A over 2. Now you should know equations, algebraic equations. You can multiply up here. And if you do on your calculator, sine 45 times 2, A, this leg here, A will be about 1.414. Or you could just say about 1.4. Just multiply up. That's all you had to do. Let's do a few others. Oh, by the way, let's look at the rule. And you can use rules sometimes without having to use these trig ratios. So let me just draw this again. The rule here, the ratio is, again, leg A and leg B will be the same, and the hypotenuse will be that leg times the square root of 2. So we already know that this is 1.414. So this has to be 1.414. And this has to be 1.414 times the square root of 2, which will give you 2. So you can do it that way also. All right, let's clear this out, do a few more. Clear it out. And let's ignore these dashes over here, these lines. Let's say that we have a degree. Well, let's say we have 50 degrees. Why not? We have 50 degrees. We don't know what A is. Again, let's ignore that, and let's ignore that. And let's say that this leg over here was 7. Right? How could we get A? How can we get A? What ratio can we use? Well, we have 50 degrees. We don't know the opposite. We're trying to find the opposite. But we do have the adjacent, 7. So we could use tan. We can use tan 50 degrees. because we have an opposite over adjacent. So tan 50 degrees, we don't know what the opposite is, but the adjacent is 7. So we can just multiply up. Multiply that up in your calculator, and you'll get A equals about 8.342. All right, let's do more. By the way, this is the TI-84 Plus, and as you can see, let's get my pen ready over here. Let's stick with red, right? We have the sine button here, the cosine, and the tangent. And you can see right here in yellow, if you press the second button, you can see cosecant, secant, and cotangent right over there on the bottom, in the back in yellow. So let's leave that up, and let's say I had a triangle here, right triangle. And we know it's right triangle. There's that little box. Let's say I had 8 and I had 17, and we don't know the degree, so we're just saying angle theta. So we're saying how can we get the angle now? Well, opposite over hypotenuse, so we can use sine theta is 8 over 17, opposite over hypotenuse. So the first thing is if you divide 8 by 17 on your calculator, go ahead and do it. Do right there. You know how to do it, right? 8 divided by 17, you'll get this long answer. And you don't have to write it down because you can save it. It's saved in the calculator. And what you'll do to get the degree now, these are the buttons you're going to press. I'll write them over here. You're going to press the second button right there. Remember, don't clear this out. So if you press second sine, second, there's the second button, sine, and then you're going to press the second button again, and then press answer. Answer button is right here, what I'm circling now. If you do that, you're going to get a degree. And the degree you get is about 28.07. Give it a shot. So if you did that, you would see it's 28.07 degrees. So we know that angle theta now, or theta, whatever you want to call it, is now 28.07. So let's just check that. And we'll make this again. We'll use blue. And now we know it's 28.07. And let's say we just didn't know what the hypotenuse was. Well, let's say we did, and we don't know what the angle A is, right? Little dot there, we'll just say A. So we can say sine 28.07 degrees equals A over 17. And all you have to do is multiply up. So go ahead, try that. If you multiply up, what do you get? And when you do that, again, you're going to press 17 times sine 28.07. Sometimes you have to press in ending the parentheses there. And on my calculator, because it's not exact, I'm getting 7.99934. It's basically 8. And by the way, if you didn't use, let's say and we'll change the color again, use purple. Let's say, for example, that you used 28.07, but we didn't know the hypotenuse, but we knew that was 8. So you're doing the same thing. You're doing sine 28.07, 8 over h. Now this time you have to divide down. Remember the rule, multiply up, divide down. So it would be 8 divided by sine 28.07. Now if you do that, you'll get 17. All right. All right, let's try one more. Let's clear that out. Let me get my color in. Let's use that color. Oh, let's use black. Why not? So I'll make a right triangle here. Why not? And let's say now the degrees up here, and we'll make it 40 degrees. We don't know what that is. And let's say that the hypotenuse is 18. So if we look opposite, there's nothing there, so we just put a question mark. We're trying to find x. So we have 40 degrees equals, well, we have the hypotenuse, and we're trying to find x, and x is what? It's adjacent. So we should use adjacent over hypotenuse, which is cosine, right? So cosine 40. And again, all you do is just multiply up. Try that. What'd you get? Pause the tape if you need to. And you should have had 13. And again, it's like a big number, like 7887. So you could roughly say it's 13.78, 13.79, roughly around there. All right, so that is trig ratios.